Hello, let's start with our sum of n number recursive problem which we have discussed previously. So see, when we have written a function n sum, as I said, you will have one base case. So this is the base case for this problem. I'll write it as a base case. And this is your actual recursion. So now in this problem, I'm just taking values which are positive. So if you want to just take any of values like starting from 1, so this code works. If someone enters the negative value, n to be negative value, so you can just add one condition here that please enter a positive number. That is the only thing which is missing in this code. But let's understand exactly how recursion works, and then we'll discuss some more examples in subsequent videos. So see, what we have given sum of first n numbers, and if n is equal to 1, so that is because we are summing n numbers. If n is equal to 1, then we are going to return 1 because sum of first 1 numbers is 1. Else it is returning n plus n sum of n minus 1. So we are decreasing n by 1. So this method is also called as decrease and conquer. So we are actually decreasing n value by 1. So we are actually starting with the larger problem. So whatever value of n is there, suppose n is 100. So you are starting with n equal to 100 and you are decreasing that problem till the base case. That is, our base case is 1. So till n equal to 1 we are going to decrease our problem. So this is the decrease and conquer recursion problem, we can say. So now we'll just take one example and we'll see how it works. So let's take n equal to 4 in this case. So now what will happen if I choose n equal to 4? So now I'll just write first case, that is n sum of 4. So now I am calling n sum of 4, and what answer I'll be getting here, n sum of 4 is equal to, you can see that this is n sum of 4. Is n equal to 1? No. So n is not equal to 1, so we are not entering into this loop. So we are going here, and what we are going to return, n plus n sum. So n is here 4 plus again n sum of 3, right? N minus 1. So now n became 3. So now here I am going for n equal to 3. So now again n sum of 3 is what? Because you can see in n sum of 4 we didn't get a perfect answer because it is 4 plus n sum of 3, because this function has returned again a same function with one value decreased. Okay, so now what n sum of 3 will be getting? N sum of 3 is again 3 plus n sum of 2, right? So now when you go to n equal to 2, you are getting n sum of 2 is equal to 2 plus n sum of 1. So you can see that these three cases, first case I got 4 plus n sum of 3, second case 3 plus n sum of 2, and third case 2 plus n sum of 1. So in all these three cases I am not getting any answer. But now when you are going to reach n equal to 1, so you can see that now for n equal to 1 our base case is true. So I am getting n sum of 1 which is equal to 1. So now after 4 steps, because I have taken n equal to 4, I have decreased that problem from 4 to 1, and now at the 4th stage I got the answer 1. So go on doing back substitution everywhere. So now n sum of 1 is 1, so I am getting n sum of 2 as 2 plus 1. Now n sum of 2 I got calculated here, that you back substitute here. So n sum of 3 will be, so here it is 2 plus 1 after back substitution, which is equal to 3. Now this is 3 plus 3, which is equal to 6, and now this value you should back substitute here, that is 4 plus 6, and I am getting final answer as 10. But in this process, if you just see, when you started with the larger problem, so n equal to 4, but it calculated n sum of 4 first, but you didn't get the answer. Then you went for n sum of 3, you didn't get the answer, till you reached the base case where n sum of 1, we got the answer as 1. So now how the compiler will understand that now I have to take like I got the answer, now I have to add this 1 to n sum of 2, and where these values will be stored, because every time you are calling the functions, right? So there is one data structure that is called as stack. So these values will be stored on the stack and to access the stack element, we will be actually accessing the top of the stack by using pop. There are two operations on stack. To pop, take the top of the stack out, and to push. Push means push something on the stack. So right now let's assume for this problem we have empty stack here. So this stack is empty and I am just keeping these lines here. So now when I push the first value, so where I am calculating n sum of 4, if I push, because I didn't get the answer here, so I will be pushing it. So I will be pushing that value here, that is n sum of 4, which is at the top of the stack now. Now the next value where I calculated n sum of 3, this answer also I didn't get, so that also value will be pushed on the top of the stack. So that will go over n sum of 4. So I will be writing here n sum of 3 over n sum of 4. So this is n sum of 3. And now here again I didn't get the answer, so I will write n sum of 2 over n sum of 3. So now we got here as an answer. So now once you get the answer, just check back what is n sum of 1 we got here as 1. So now go for the n sum of 2, and n sum of 2 is what? N sum of 2 value we have already pushed it over the stack, that is 2 plus n sum of 1, so which will be equal to 2 plus 1. So you are now popping the top of the stack. So when I have pushed on the stack, this was initially at the top, then over this value came, and over this n sum of 2 came. Now I am popping, so it will pop out the top value of the stack. Okay, so it will be 2 plus 1. Then n sum of 3 again will be top of the stack, it will pop. So once you popped this value will be go out of the stack. Now top of the stack is n sum of 3. So now n sum of 3 is what? 3 plus n sum of 2, which is 3 plus 3, which is equal to again 6. And then now n sum of 4 I have to go. So when I popped 3 is also taken out of the stack. Now top of the stack is n sum of 4, which is equal to 4 plus n sum of 3, that is 4 plus 6, which is equal to 10. This is our final answer. Hope you have understood this, and we will see some more examples in further videos. Thank you.